Hello everyone. Today I'm going to talk with you about redox reactions. These are reactions where a transfer of electrons occurs. And these can take place between atoms, molecules, and ions. So actually all kinds of particles. The term redox comes from the reactants, the reductor and the oxidator. So you can see that this determines the term redox. The reductor is the atom that gives electrons, and the oxidator is the reactant that takes the electrons. You can recognize a redox reaction two ways. You can see, first way is to see that the charges of the particles changes. Charges change. And the second way to see is that elements can be made or destroyed. Or disappear. So I will give some examples. For instance, a reaction between H+ and zinc. Which gives H2 and Zn+. If you look at it both ways, first the first way, you see that here H has a we'll do it. Here it has a charge of 1+, and here it has a charge of 0. So you see that it needs to get one minus charge, so it gets one E-. In other ways, your H is your oxidator, because it takes one E-. And here Zn has a charge of 0, and here it has a reaction of 1+. So it gives away one electron. In other words, it's a reductor. So you see that the charges of the atoms change. So you have a redox reaction, which you can also see if you look at the second way, that H2 is made, which is of course an element. So there are two ways to spot that this is a redox reaction. If I give another one, the electrolysis of water. Here you can't see clearly a difference between charges, but you can see that H2 is formed and OH2 is formed, which are both elements. So there's a redox reaction. The only kind of reaction you have to pay attention to is a reaction like this, between Na+ and Cl-, or NaCl is made. You might say, oh, here Na has a plus charge, here it is 0, and the same for Cl, here it has a minus charge, here it's 0, so it is a redox reaction. However, this reaction makes a salt, which is made out of a metallic atom and a non-metallic atom, or ion. And in this case, in salts, the charge is actually still present even though it is in this form. You don't write it usually, but it is still present because the electronegativity between the Na and the Cl is of such big difference that the charge are practically still on the atoms. So the metallic is in this case the sodium, and the non-metallic is the Cl minus. So if you spot a reaction between a metallic and a non-metallic ion, it isn't a redox reaction, but it is a reaction that makes salts.